For most of human history, we believed the universe was slowing down, not because we had measured it directly, but because it had to be true. Gravity pulls. Matter attracts matter. After the Big Bang, after everything was flung outward, the fundamental force governing the cosmos should have been pulling it all back together, slowing the expansion with each passing billion years. This was not a guess. It was physics. The universe was expanding, yes, but that expansion had to be decelerating, losing momentum. The only question was how much. Whether the universe had enough matter to eventually collapse back into itself, or whether it would coast forever, fading into cold stillness. Either way, the universe was winding down. That much was certain. And then, in 1998, we discovered it was not. The measurements came from distant supernova, exploding stars so far away their light had been traveling for billions of years. By measuring how bright these explosions appeared and how much their light had been stretched, astronomers could calculate distances with precision. If expansion was slowing, these galaxies would be closer than expected. The data should have shown deceleration. It showed the opposite. The galaxies were farther away than they should have been, which meant billions of years ago, the universe was expanding more slowly than it is now. Expansion had not slowed, it had accelerated. Scientists checked everything. Independent teams verified the results. The measurements held. The universe is speeding up. There is no known force that should cause this. Gravity attracts, it does not push. And yet something is overpowering gravity on the largest scales. Something vast and invisible is dominating the entire cosmos. They called it dark energy. The name is not an explanation, it is an admission. Dark because we cannot see it. Energy because it behaves like pressure filling space. But beyond that, almost nothing is known. Dark energy does not emit light. It does not absorb light. It does not clump into galaxies. We have never detected a particle of it. We only know it exists because we can see what it does to the universe, and what it does is push. Roughly 70% of the universe is dark energy. Not dark matter, not ordinary matter, something else. Something that does not dilute as space expands. Most of reality is made of this, and we do not understand it. For decades, the simplest explanation was that dark energy is constant, a fixed property of empty space. This fit the observations. It allowed scientists to model the universe's future. The cosmological constant became the default assumption. But recent observations are beginning to suggest something else. New data hints that dark energy may not be constant, that its density may be changing over time, that the force driving cosmic acceleration may be growing stronger. This is not yet confirmed. The uncertainties are large, but the tension is real. Multiple surveys are finding results that do not quite match the constant model. The discrepancies are small, but they are persistent. Some measurements suggest that dark energy was weaker in the past, that over billions of years it has strengthened, not dramatically, but steadily. Enough that our most precise instruments are beginning to detect the difference. If this is real, everything changes. A constant dark energy is strange but stable. It allows the universe to accelerate smoothly toward a distant, cold future. But a dark energy that strengthens is something else. It is dynamic, unstable. It implies the expansion is accelerating towards something more extreme. This challenges modern cosmology. Einstein's equations allow for a constant, but they do not easily accommodate a varying dark energy. If it is changing, something deeper is at work, a mechanism we have not yet discovered, and we do not know what happens next. The measurements are extraordinarily difficult. Dark energy does not announce itself. Its effects are subtle, visible only in the large-scale motion of galaxies and the geometry of space-time. Scientists observed distant supernovae, measuring how fast the universe was expanding at different points in history. They mapped billions of galaxies, looking for patterns shaped by dark energy. They analyzed the cosmic microwave background, searching for imprints in the temperature fluctuations. Each method is independent, but when combined, they tell a story, and that story is beginning to deviate from predictions. Some galaxy surveys suggest that structure formation does not perfectly match models based on constant dark energy. Some supernova measurements hint at variations that are hard to explain if dark energy has remained unchanged. The uncertainties are significant. Any single measurement could be wrong, but multiple independent methods finding similar tensions is unsettling. If dark energy is strengthening, the future is not what we thought. With a constant, the universe expands forever. Galaxies drift away, stars burn out. The universe fades into darkness over trillions of years. But stable. If dark energy is increasing, the timeline accelerates. Expansion grows faster. The cosmic horizon closes in more quickly. Eventually, even structures held together by gravity begin to feel the strain. In a universe where dark energy strengthens indefinitely, expansion begins to overwhelm gravity on smaller scales. Galaxy clusters break apart, then galaxies, then solar systems, then planets, then atoms. This is the Big Rip, a future where accelerating expansion tears apart every structure in the universe. The exact timeline depends on how quickly dark energy strengthens. But if the effect is real and continues, the outcome is catastrophic. We do not know if this will happen. The data is not conclusive, but the possibility exists because dark energy remains fundamentally mysterious. What troubles physicists is the implication. Science has assumed the universe is governed by stable, universal laws. That constants are constant, that equations apply everywhere, at all times. If dark energy is changing, that assumption is threatened. The universe is not in equilibrium. The forces shaping it are evolving. This is not the first time assumptions have collapsed under new evidence. Each time, the adjustment was difficult. It required accepting that intuition is not a reliable guide to reality, learning to live with questions that have no immediate answers. But each time, the effort led somewhere, to new theories, new ways of understanding the cosmos. We may be entering such a moment again. The tools are improving, new telescopes are launching. The Vera Rubin Observatory will survey billions of galaxies. The Euclid telescope is measuring gravitational lensing. James Webb is observing the early universe when dark energy's effects were beginning. These missions will produce data, and that data will either confirm the constant or rule it out. If dark energy is truly strengthening, the evidence will accumulate. The tension will grow too large to ignore. Physicists will have to build new models. Some will suggest modifications to relativity. Others will propose exotic fields. Still others will question whether observations are being misinterpreted. This is how science works. It tests, it measures, it revises. But openness to being wrong does not make it comfortable. If dark energy is changing, we live in a universe less predictable than we believed, where the dominant force is not fixed but dynamic, where the future is not determined by equations we already understand. And we are discovering this now because the universe is revealing itself through measurements so precise they expose discrepancies we could not have detected before. We live at a rare moment, a time when the universe is still observable. Galaxies are still visible. The cosmic microwave background still carries information. Stars still illuminate the void. This will not last. Whether dark energy is constant or strengthening, the universe is expanding, accelerating. The distances are growing. More of the cosmos slips beyond reach with each moment. Future civilizations will not see what we see. They will inherit a universe where galaxies have vanished, where evidence for the Big Bang has disappeared, where the cosmic web has dissolved. We live now in a window when the universe is revealing its nature, when instruments can detect dark energy's effects, and what we are seeing is unsettling. Not because it threatens us immediately. Dark energy does not affect planetary orbits. It operates on far larger scales. On human timescales, it is irrelevant, but it changes what the universe is, where it is going, and how we understand our place within it. We are learning that most of the universe is invisible, that familiar matter comprises less than 5% of reality, that the dominant components are substances we do not understand. We are living in a universe where the familiar is a tiny minority, where forces shaping everything operate beyond perception, where the future is being determined by something we cannot see. And if dark energy is strengthening, we live in a universe that is not stable, not settled, but accelerating, changing. evolving in ways we cannot predict. This is not comfortable. It does not provide closure. It opens questions rather than answering them. But it is honest. Science does not promise the universe will make sense. It does not guarantee reality will conform to human intuition. It only promises to follow the evidence. And the data is beginning to demand revision. Dark energy may be changing, growing stronger, pushing the universe toward a future we have not fully imagined. We do not know why this is happening. We do not know what dark energy is. We do not know if it will continue to strengthen or if some process will intervene. These are real questions, open, unanswered, and they will define the next era of cosmology. The missions are launching, the data is arriving, the measurements are becoming more precise, and with each observation, the picture becomes clearer or stranger. Scientists are not afraid of being wrong. They are afraid of not asking the question, of assuming the universe is simple when it is complex. Dark energy is not just a scientific problem. It is a reminder that the universe does not owe us simplicity or predictability. Something vast surrounds everything we know, something invisible, something that makes up most of reality, and it may be getting stronger, not quickly, not catastrophically, not in a way that will affect us in our lifetimes, but steadily, quietly, persistently. The universe is changing. It has always been changing, but now we are beginning to notice, beginning to measure, beginning to understand that the cosmos is not a static backdrop, but a dynamic process. And that process is accelerating, driven by forces we do not comprehend, toward futures we cannot predict, carrying everything farther apart into the unknown. We are watching it happen, measuring it, trying to understand it. But understanding may require letting go of certainty, accepting that the universe is stranger than we thought. More complex, less predictable. The stars are still shining. The galaxies are still visible. The structure is still intact. But something fundamental is shifting. Something we cannot see. Something we are only beginning to measure. Something that may be growing stronger while we watch. And we do not know why.